Hey guys, Mr. B here. In this video, we're going to be going over the practice problems in the chapter 11.3 notes. Alright, so starting with number 1, it says write a balanced net ionic equation for this reaction. Okay, so it looks like they're giving us a complete ionic equation with everything already broken apart, so that's nice. We just need to write the balanced net ionic equation. So net ionic equation means that we're going to remove any spectator ions. So if you look at number 1, any ions that are exactly the same on both the reactant side and the product side, we need to get rid of. So on the reactant side, we have Ca2+, and on the product side, we have Ca2+. So that's a spectator. We have PO43- on the reactant side and PO43- on the product side. That's also a spectator. So we're not going to have those, which means that our net ionic equation is going to be OH-, which is AQ, plus H+, which is AQ, and those are going to make H2O, which is a liquid. Now, in the notes, we mentioned how we usually want to have one of these products be a solid, and in this case, we're actually making a liquid, which is not a solid. When we have these kind of chemical reactions, we actually don't need to make a solid. We just need to make something that is not aqueous. Okay, so if we have two products that are both aqueous, the reaction won't happen. If you make a solid, if you make a gas, if you make a liquid, anything that is not aqueous, that will make the reaction happen. So in this case, we're making water, which is a liquid that is different from the ions which were aqueous to begin with. Therefore, this reaction takes place. And we do need to balance it, or at least we need to look to see if it's balanced. We have one oxygen on the left-hand side. We have one oxygen on the right-hand side. We have two H's on the product side, and on the reactant side, we have one H here and one H there. So this is actually already balanced. This is all we're looking to do. This is our net ionic equation. All right, so let's take a look at number 2. So number 2 here says identify the net ionic equation for the following equation and the spectator ion if there is one. Okay, so first, I think we need to balance this. It doesn't look balanced to me. We have one iron on the left and one iron on the right, so that's fine. We have one oxygen here and one oxygen here, so that's good. But we have one H here and two H's there. So I think first we need to balance this equation because otherwise this is going to be really confusing. That also gives us two ClO4 ions. And we have two ClO4 ions right there. So that's balanced out. All right, so now that this is balanced, let's take a look and see if we can identify what the correct net ionic equation is. So maybe first, let's break this apart ourselves, and then we can see which of these choices looks right. All right, so remember that when we're writing a net ionic equation or any complete ionic equation, we want to keep things that are solids together or things that are not aqueous together, and anything that's aqueous we write separate. So we have FeO, which is a solid, so that we have to keep as a solid. It's not aqueous. We can't break it apart. But we have 2HClO4 aqueous. All right, so we have two H+ ions, which are aqueous, with two ClO4 ions, which are aqueous, and this is a perchlorate ion. Okay, this is a polyatomic ion. You can find it on the back of your periodic table. In fact, you know what? We'll even pull up our periodic table just to show you. If we go look at the list, we can find the ClO4 ion right here, perchlorate. Okay, ClO4. That's a perchlorate ion. So we have two H+ ions in this compound and two ClO4- ions in this compound. Those are both aqueous. So we're going to write them as separate things. On our product side, we have H2O, which is a liquid. So because that's not aqueous, we're going to write it as it is. And then we have FeClO4-2, which is aqueous. So that needs to be written apart as well. So we're going to have Fe. The charge on it is going to be 2+. Okay, and I know that this is 2+, and here's why. ClO4, okay, that's chlorate. And this has a charge of -1. Okay, we have it written right over here. And there are two of them So total, that's a charge of -2. And there's only one iron here bonded with that, which means that iron needs to be +2 to balance out the -2 from the perchlorates. That's how I know the charge is +2. Okay? So there's an Fe2+ ion, which is aqueous. Plus, we have 2 ClO4- ions, which are aqueous, like this. Okay, so this is everything that we know of. Okay, this is everything that we have. This would be our complete ionic equation. And they're asking in this question to identify the net ionic equation and the spectators. All right, so spectator ions, if we look on both sides, what do we see that's the same? This is not the same. That's different. This is not the same. That's different. This, however, is the same. So this would be our spectator ion. So I'm just going to do a little straight through here to know that that's our spectator. Okay. So our spectator ion is that, which means of all of our choices, it's either going to be B or C. And of these two, B or C, the net ionic equation is just going to have these two things here and these two things. So it looks like we would have C as our answer, where we have FeOS as a solid on the left with 2H plus AQ on the left. And we have H2O liquid on the right with Fe2+ aqueous on the right. And they've identified this as a spectator, which we also identified. So our correct answer here is letter C. Okay, that's our correct choice. All right, taking a look at number 3. It says, which of the following products of double replacement reactions would not form a precipitate? All right, so we are going to be looking on the back of a periodic table at our solubility chart to see which of these would not be a solid. Okay, so we want it to be aqueous for this question. It's basically saying which one of these is aqueous. So let's go take a look at the back. The first one we have here is silver chloride. Okay, so we'll take a look at that one first. So let's go take a look at silver chloride. So we have silver, which is here, and chloride, which is here. And this says S for solid. All right, so that one cannot be the answer because it says which would not form a precipitate, and this one would form one as a solid. So it can't be that one. Okay, letter B here, PbSO4, that is lead 2 sulfate. So let's go take a look at lead 2 sulfate. So let's find lead 2, which is here, and sulfate, which is here. And this would be a solid. Okay, so it can't be that one either. So this one, letter B, would not be the correct choice because that would also form a precipitate. All right, letter C, we have MgOH2, so that is magnesium hydroxide. So let's go take a look at magnesium hydroxide and see if that one would form a precipitate or not. So we have magnesium here and hydroxide, which is here, and that would make a solid as well. Okay, so that pretty much then leaves letter D as the correct choice. But we will check it anyway just to see. So we have CuSO4. That would be copper 2 sulfate. So let's take a look at copper 2 sulfate. All right, so we have copper 2, which is here, and sulfate, which is here. And we see that that one is aqueous. All right, so it looks like of these four, the one that would not form a precipitate would be letter D. All right, number 4, write the net ionic equation for the reaction between aqueous barium nitrate and sodium sulfate. All right, so for this one, we're going to need to write out first the regular balanced equation, then the complete ionic, and then the net ionic. Okay, so we're going to do 3 equations here. All right, so first let's just write out the regular balanced equation. If I can type here, balanced equation. There we go. All right, so we have BaNO3, 2, and it is aqueous because it says so in the problem, plus lowercase a, Na2SO4, also aqueous. Now there's going to be double replacement, so the Na is going to bond with the nitrate, so we're going to have NaNO3. We'll check if that's aqueous or not in a second. And then the barium, Ba, is going to bond with the sulfate, so we'll have BaSO4. Okay, so these are 2 products. Now, from here, we need to go check to see if either of these will be a solid or if they'll both be aqueous. If they're both aqueous, this reaction will not happen, in which case we're wasting our time. I would guess one of these is going to be a solid, though. So we have sodium nitrate We have sodium nitrate, barium sulfate. So let's go check our chart. Okay, so first we have sodium nitrate. So sodium, oh, let's get rid of that. All right, so sodium is here. Nitrate is here. This looks like it is aqueous. So let's go mark that. So this one here is aqueous. Okay. And then the other one was barium sulfate. So we have barium, which is here, and sulfate, which is here. And this one says solid. All right, so that is our precipitate, which is good. Again, one of these needs to not be aqueous in order for this reaction to happen. All right, so that one is a solid. Cool. All right, so from here now, we're going to write our complete ionic equation. So anything that is aqueous, we're going to write as separate ions, okay, pulled apart. And anything that has a solid, we're going to keep together. So we have a barium ion, which is Ba2+. Okay, that's aqueous. That is bonded with 2 nitrate ions. So 2 NO3 ions, which are aqueous, plus we have 2 sodium ions. So 2 Na plus ions, which are aqueous, and that is bonded to 1 sulfate ion, which is aqueous. Okay, so there's 1 sulfate here. That is SO4 2-. All right, so those are all of the things that we have on the reactant side. Everything broken apart as ions that are aqueous. On the oh, I forgot we didn't balance this actually. We need to have a 2 here. It looks like. I apologize for that. So there needs to be a 2 here to balance out the sodium. So luckily that doesn't change anything for this part we wrote here. But for the product side, it will change some stuff because we didn't write that part yet. All right, so let's shift this over just to make it a little bit wider so we have enough space, hopefully, here. All right, so we have 2 sodium ions that are aqueous. Plus, we have 2 nitrate ions, okay, here, which are aqueous. So 2 NO3 minus ions, which are aqueous. Plus, and then this here, since it's a solid, we're gonna keep it as a solid, okay? So this is going to be BaSO4, and that's a solid. I'm going to make this font a little bit smaller so that this is all on one line because I don't want to have it on 2 lines. All right, so here's our complete ionic equation. Okay, again, these things that are aqueous come from this stuff up here. Okay, so this is aqueous, this is aqueous, this is aqueous, so that's why all this is written separately. This is aqueous here, okay? So we have the 2 sodium ions that are aqueous written here as ions. We have the 2 NO3 ions that are aqueous written as ions. And then this, which was a solid, is written as a solid, okay? So there's our complete ionic equation. And then the last part here is to write our net ionic equation, which is removing the spectator ions and only writing what we have left. So if we look at our complete ionic equation, we have 2 NO3 minuses on the left, 2 NO3 minuses on the right. So that's a spectator. We have 2 Na plus ions on the left and 2 Na plus ions on the right. That's a spectator. So we can cross these off. Okay, so we're going to go straight through. So cross that off, format, straight through, cross that off. And then on this side, we'll cross these off too. And then everything that we have left is what we're going to write out for our net ionic equation. All right. So net ionic equation is then going to be the Ba2+ ion, which is aqueous, plus the SO4 2- ion, that is aqueous. And then we have on the product side just the BaSO4, which is a solid, okay? And that is our net ionic equation. That's what they're looking for, is that last part right there. All right, so again, this whole section of stuff really comes down to how good are you at writing your chemical formulas for ionic compounds, okay? If you struggled with writing chemical formulas for ionic compounds, you didn't understand how do you know the charge on an ion, how do you break it apart, all that stuff, go back and watch Chapter 9 videos or reach out to me so that I can work with you one-on-one and make sure that you are comfortable with this, because a lot of this chapter is on writing chemical formulas, and this last part particularly is just all chemical formula stuff. So that's it for this section of notes. That's it for these problems. And as always, if you have any questions, make sure you reach out and ask. All right, I will see you in the Chapter 11 review guide. Bye.